Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 219. Please turn to it, page 219, problem number 6. Problem number 6 on page 219 is the exact same problem that appeared in the first edition of the book. We have already solved every single problem from this book. If you're interested in watching the original solution, you will find the original solution on day number 81. As a matter of fact, in this case, I insist that you watch day 81 and day 79 if you have not already done so, because in those 2 days we spent quite a bit of time learning about the concept of prime numbers. I'm not going to go into that much of a detail here. We're just going to quickly go through the list and we're just going to decide whether or not a given number is a prime number. But if you need to know the reason behind it, if you need to understand the logic behind it, go and watch the original videos, day 79 and day 81, and there you will find the in-depth explanation. Let's get going here. So here we are being asked, in question number 6, we are being asked which of the following are prime numbers, and here's the list. 2, 9, 19, 29, 30, 37, 45, 49, 51, and finally 83, 90, and 91. Well, what's a prime number? A prime number is the number that can only be divided by itself and 1, and 2 meets those two conditions. Therefore 2 is the only even number that's a prime number. The only two numbers that you can divide 2 by, it is self and 1. 2 is a prime number, that works. 9 is not a prime number because 9 can be divided by 3. 9 is a perfect square. 19 is a prime number. 29 is a prime number. 30 is not a prime number. No even number can be a prime number, because if it's an even number, obviously by definition it can be divided by 2. Other than itself and 1, it can be divided by 2. The only exception is 2. 2 is the only even number that's a prime number. No other even number will qualify as a prime number. 37 is a prime number. 45 is not a prime number, because anything that ends in a 5 or a 0, if a number ends in a 5 or a 0, is divisible by 5. Forget about any other, don't have to worry about any other thing. We just have to find one exception. In addition to 1 and itself, all the numbers are divisible by themselves and 1. That's just a theoretical requirement. Other than that, 45 can be divided by 5. It's not a prime number. 49 is not a prime number, because again 49 is a perfect square. You can divide it by 7. What about 51? 51 is an odd number, and when you come across an odd number, of course odd numbers are the only ones that you're worried about, because you don't have to worry about even numbers. Even numbers are not prime numbers, except 2, of course. When you come across a number and you're trying to decide whether or not it's a prime number, ask yourself, very first question that you want to ask yourself is it divisible by 3, before you worry about anything else. Because a lot of the time people miss that. Is it divisible by 3? How can we tell if a number is divisible by 3? It's very simple. Here's the rule. A number is divisible by 3 if the sum of its digits is divisible by 3. Sum of the digits of 51 is 5 plus 1 is 6. Sum of the digits is 6. Sum of the digits of 51 is 6, and 6 is divisible by 3. Therefore 51 is divisible by 3. 51 is not a prime number. We can divide 51 by 3. How many 3's in a 5? 5 has 1 3. The remaining 2 goes and joins the 1, becomes 21. How many 3's in a 21? 21 has 7 3's. Therefore 51 is not a prime number. We can divide it by 3. We can divide it by 7. 17. 83 is a prime number. And again, how do we know 83 is a prime number? I'm not going to go into in-depth discussion here. As I said, this is where you're going to find it. 83 is a prime number. 90 is not a prime number. Obviously, it's an even number. What about 91? Again, saying one more time. Ask yourself, what's the sum of the digits? Sum of the digits is 10. 9 plus 1 is 10. And of course, 10 is not divisible by 3. Therefore, 91 is not divisible by 3. Next on the list is 5. We have to go and list. 2, 3, 5, 7, 11, and so on and so forth. You have to check all the prime numbers to see if you can divide this number by any of the prime number. Next in the list is It is not divisible by 2 because it's not an even number. It's not divisible by 3 because sum of the digits is 10. It's not divisible by 5 because it doesn't end in a 0 or a 5. The next one is 7. Let's see if 91 is divisible by 7. Let's see if we can divide 91 by 7. Those are the two you have to worry about. 3 and a 7 are the dangerous ones. Those are the ones you must always check before you decide, before you declare that something is a prime number. Before you declare that the number is a prime number, always make sure that you check for 2. Always make sure that you check for 3, 7. 11 is very simple actually. If it's a two-digit number, then the digits have to repeat themselves. But you have to check for 3 and 7. Let's find out if 91 is divisible by 7 or not. How many 7s in a 9? 9 has 1 7. Remaining 2 goes and joins the 2 becomes 21. 21 has 3 7. Oh, what do you know? 91 turns out equals 7 times 13. 7 times 13. Is that right? 65 is 5 13s. 5 13s. No, that's not right. 1. The remaining 2 goes here, becomes 21. That's 13. That's right. 13 times 7. Oh, that'll be 6. This will be 6 13s. This will be 6 13, and one more 13 will give us 1. Ah, there you go. There you go. This is 5 13s. This was 6 13s, and this is 7 13. That's right. Even though I got it here, I was doubting it myself. It is 7 13. Therefore, 91 is not a prime number. It can be divided by 7 and 13. That's it. That's all. As far as this problem is concerned, we are done. Now I want to do something different. That's it. We are done with this thing, but we're going to do something else with it. Stay with me in this story. That's it. We are done with all of this thing. We need to erase it. This is not what we are about to do. It's not in the book. This is something bonus. Here's the new questions. The new question is, what are the prime factors of 9, 30, 45, 51, 90 and 91. This problem that we are about to do is very similar to problem number 5 and problem number 7. Problem number 5 and problem number 7 are the two problems that we did yesterday on day number 297. Yesterday, previous video. This what we are about to do is very similar to it. Will you be able to tell me very quickly the prime factors of all of these numbers? Let's begin with 9. 9 is very straightforward. 9 is a perfect square. Therefore, the only prime factor of 9 is 3. Similarly, do we have any other perfect square here? Oh, I left out 49 here, didn't I? Let's take 49 in here. Similarly, the only prime factor of 49 is 7, because 49 is going to be 7 squared. Now let's do all the others. 30 divided by 2, we get 15. Divided by 3, and we get 5. Therefore, the prime factors. So that's it. We're done with 9 and we're done with 49. I'm going to erase them. Prime factors of 30 are 2, 3, and 5. Let's do the next one. 45. 4 plus 5 is 9. Since sum of the digit is 9, which is divisible by 3, therefore 45 is divisible by 3. 4 has one 3 in it. How many 3s does 4 have? 4 has 1 3. The remaining one goes and joins the 5, becomes 15. 15 has 5 3s in it. Divide one more time. So it looks like 3 times 5. Therefore, prime factors of 45 are 3 and 5. Let's go to the next one. Next one is 51. Again, 51. The sum of the digits is 51. The sum of the digit is 6. Therefore, it can be divided by 3. How many 3s in a 5? 5 has 1 3. The remaining 2 goes and joins the 2, becomes 21. How many 3s in a 21? 21 has 7 3s. That's it, 3 times 17. So therefore, the prime factors of 51 are 3 and 17. Let's go to the next one. 90. 45, 3, 1 and 5, 3 and 5. There you go. Therefore, prime factors of 90 are 2, 3 and 5. There are 3 prime numbers that you can divide 90 into. You can divide 90 by 2 evenly, you can divide 90 by 3, and you can divide 90 by 5. You cannot divide 90 by any other prime factors, it won't divide evenly. Let's go on then, 91. What about 91? Sum of the digit is 10, which tells us that it cannot be divided by 3. It cannot be divided by 5, obviously, because it doesn't end in a 5 or a 0. Let's try dividing by 7. How many 7s in a 9? 9 has 1 7. Remaining 2 goes and joins this guy, becomes 21. The remaining 2 goes and joins the 1, becomes 21. And 21 has 3 7s. 3 7s are 21. Therefore, prime factors of 91 are 7 and 13. Well, that's it. And that's how we find prime factors of a given number quickly. As I said, this is very similar to what we did yesterday, where we solved problem number 5 and problem number 7, except they had given bigger numbers to us. We had 100, we had 144, and we had 585. Now when people see 585, they freak out. They say, well, how long is that going to take to figure out the prime factors of 585? It's very simple. We did that. 585 goes very quickly. 585 goes very quickly. 585. Even though the rule dictates that I check for 3 first, I'm going to be lazy. I'm going to violate that rule, but just don't tell anybody. I'm just going to do by 5 very quickly, because I see a 5 here. We know it's divisible by 5. So we get 1. How many 5s in an 8? 8 has 1 5. The remaining 3 goes and joins the 5, becomes 17. Becomes 30. Remaining 3 goes and joins the 5, becomes 35. 35 has 7. 35 has 7 5s. Now I see 1 plus 1 is 2, 2 plus 7 is 9, this is divisible by 3. How many 3s in 11? 11 has 3 3s. The remaining 2 goes and joins the 7, becomes 27. 27 has 9 3s. Divide one more time by 3, and we get 1 and a 3, and there you go. So we can actually insert one more thing here. The prime factors of 585 are 3, 5 and 13. There you go. That's it. I will see you tomorrow when we'll begin the problems on the next page. And as far as the prime numbers are concerned, we are done. We are done talking about the prime numbers. On the following page, we're going to encounter different concepts, new concepts. But that was the last video. Actually, this was day number 299. I forgot to change this thing. Since this is day number 299, I'm going to make one more video, a nice round number of 300. Day 300, and I'm going to make one more video dealing with the concept of prime numbers, and that's going to be our last video, which is going to be tomorrow's video. where we'll do a problem that does not appear in the book. We'll do it together and see if you can figure out the answer to it very quickly. It's going to be a quantitative comparison question, but it's going to deal with the concept of prime numbers. We'll do that tomorrow, okay? Bye now.